Hi guys, so this is a guide for you on how to do activity page 4, but some of you already turned it in, but I'm just going to post a tutorial or a guide so that the others will be guided too. Or if you have any questions, you can always ask me, okay? So let me start with this one. So geometry activity page number 4. Let's begin. So for example, so this is more on problem solving. Okay, so still about properties of kites and trapezoids. So you will use this figure at the right. So let me move my face. Use this figure at the right for numbers 1 and 2. So we have here, what number 1, what is AD? To the nearest tenth. So this is AD. So just imagine that's so straight. Well, I can use the line, but hey, it's no fun. Okay, so you have here line AD and or side AD, which is the side that we're looking for number 1. So how do you get that one? So take note that that is not perfect. So this is a triangle right here, and you see that right angle right there? That means that's a right triangle. So if you have a right triangle and you have this missing side, so what you're going to do for that is that you have to find the hypotenuse. So to find that hypotenuse, just do 22 squared plus 7 squared. So you can get 22 squared first, then you get 7 squared first, and then you add them. Whatever you get the square root, okay? So this x is just the square root of 22 squared plus 7 squared. Now it says nearest tenth. That means you only have to place one decimal point, okay? So one decimal number, you always have one decimal point. Okay, so that's for number 1. Now number 2, what is the perimeter of the kite to the nearest tenth? So if you say perimeter, so that's the whole thing. So what's the measure of all the sides? So that means you're gonna add all the measures of all the sides that you can find in that kite. Now you should know by now what this side is. So whatever that side is, of course, that should be the same over here. So that and that is from number 1. They should be the same. Now we don't have this part, this AB and this BC. So we can use this because whatever this side is, you can solve for that one because whatever that side is, that's just the same to the other side. Let's use a purple one. So let's just label that Y. So to find that Y, still the same as how you did this part because that's still a right triangle. So you should do 12 squared plus 7 squared. So just use one decimal number 2 for that one, okay? So round it off. Now, so after you get that Y, you also write that over here. So they should be the same because that's one of the properties of the kite. Now, it says perimeter. That means if you add that, this, that Y, and that X, so that's just the perimeter. So add everything, okay? But make sure you have all the sides first. So that's for numbers 1 and 2. Now for number 3, so look at number 3. So in kite STUV, the measure of PUW, that's just 35. Let me see if I can make 35 as small as possible. That's 35. Okay, and then WSV, that's 21. So this is 35, that's 21. It's asking for angle UVS. So that angle right here. So this is 21, that's 35, and that's what we're looking for. And take note, they should be the same over here, okay? Because opposite angles, if you have that kite like that, they should be congruent. Those angles. Okay, now take note that that's a quadrilateral. It has four sides. So to find the missing angle, you just do 360, right? Minus whatever is given. So what are given? So you have here 35, you have there 21. So this one, they should be the same, so we can label that as an X. Okay, so if that's 35, so we have there a bisector, that means that part is also 35. And if that's 21, this part is also 21. So if you try to add them, the sum of that is just equal to 35. But for this case, let's do subtraction, but you can also do adding, okay? So 360 minus 35 minus another 35 minus 21 and minus 21. That should be equal to the 2x's that we have. So you can do 2x. So get the answer of that one. 360 minus 35 minus 21 minus 21. Get the answer, you should put it here, and then equal to 2x. Now take note, we're just looking for the x, because it's this UVS, or that x only, that we're looking for. So whatever the answer is, make sure you divide by 2 to find that value of x, because we're just looking for the x, okay? So what's that x equal to? So again, whatever you get from here, put it here, divided by 2, and that's how you get your x. That's the measure of your UVS, angle UVS. That's for number 3. Now let's have number 4. So a car window is in the shape of a trapezoid. When the window is halfway down, the top is KL, the mid-segment of FGHJ. So if KL is 23 inches, what is GH? So let's put that as an X because we don't know the value of that one. So take note, that's a trapezoid and this is the mid-segment. So if you remember to find the mid-segment, which is 23, you just add the bases. So that's X plus 28 divided by 2. That's the measure of your mid-segment, and that's how we got 23. But in this case, you're just looking for x. So to find x, you just do the opposite of the following. That means 23, you multiply by 2, and then you subtract by 8 to find that x. Okay, so again, 23 times 2, and then subtract by 28. That's how you get the x. So number 5. So trapezoid PQRS has base angles that measure 9r plus 21 and 15r minus 21. Find the value of r so that PQRS is isosceles. Now, base angles are congruent. So that means you just equate that or those expressions. So 9r plus 21, it's just equal to 15r minus 21. Minus 21. Okay, now you have to solve for r. Okay, so what you're gonna do is you can do minus 9r to the side. So 15 minus 9, that's 6r. And then opposite, you move this 21 to the left side. So plus 21. So 21 plus 21, that's it. So whatever the sum is, divide by what's 15 minus 9. So you should solve for r, okay? And then you encircle the letter of your answer. Now for this part, in Kite KLMN, find the measure of angle M. So this is a kite, so that means that's x and that's x. They should be congruent. Now, it's the same with problem number 3. So what you're going to do is you just do 360, because that's a kite. It has 4 sides, and the sum of those quadrilaterals of all the interior angles is just 360. So 360 minus 95, that's 95, don't be confused, minus 63. After you get the answer, because there are still 2 x's that are left, you divide by 2, because we're only looking for the value of x. Okay, that's it. For number 7, number 7, its illustration is somewhat confusing, but actually this is just so easy. You don't have to, you have to do something like solving, but it's quite easy. Okay, so you have here in design, 8 isosceles trapezoids surround a regular octagon. So this is the octagon. Remember, octagon has 8 sides, so that should be the octagon. What is the measure of angle B? So we're looking for this one. Okay, so from our lesson, exterior angles, or the sum of exterior angles, the sum of any polygon, the sum of the exterior angles in any polygon is just 360 divided by something. Okay, so 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8. So that's 8 sides. Now, so let's take a look. Let's just emphasize that octagon. Oh, it's an octagon, okay? It should be straight right here. Okay. Okay, now, if you extend the side from that octagon, you will form this exterior angle. So how will you find the measure of one exterior angle? If you remember, you just do 360 divided by the number of sides. So again, octagon has how many sides? So you just do 360 divided by the number of sides. Now you should get that part. Now whatever that exterior angle is, since that is just parallel to that, for that trapezoid, because trapezoid are made up of 2 parallel lines or sides, that means that is also the same as that one. So whatever answer that you have right here, that's just the same for that angle B, for the measure of angle B. And that's it. You encircle your answer. Okay, so I think that's it for today, guys. So I hope to see you soon. I miss everyone. Yeah. So that's it. So we have activity page numbers 3 and 4 due for this week. So make sure you do them, turn it in, okay? Or else you know what happens. Bye-bye and see ya.